In today's lesson, we're looking at the double angle formulae. Now, learning how to use these is just really a tweaking of what we learned in the last lesson. So in the last lesson, we saw these three formulas, and we can use these to find exact values of a whole range of extra angles. And in the last lesson, we saw how to derive each of these formulas. We actually started with the cos of alpha minus beta, remember, and then we derived the other 5 formulas from that one. Now, when you're deriving the formulas, you have to use specific methods. But if you're just using them, it's really important to know that these 3 are on your reference sheet. So in an exam situation when you need to just use them, not derive them, you can just use them straight off the reference sheet. And if you're needing to use one that is alpha minus beta, then you can actually just change the sign anywhere that it is in this formula. Note that if you're proving one of those other formulas, then you can't just change the sign. You need to make the substitutions and then provide the reasoning with reference to it being an odd or an even function. So we went through all of that last lesson. So this is something that we should be familiar with. Now, today's lesson just takes that a tiny bit further and says, well, what about if these 2 angles we've got, alpha and beta, are exactly the same? Then we've effectively got sine of 2 lots of alpha, or you could say 2 lots of beta. Now, to avoid the confusion of saying, should we call it alpha or beta if they're the same, let's let them both equal theta, okay, the most generic name that we usually use for angles. So you can see how this works here. If we had the sine of theta plus theta, we would have the sine of 2 theta. And what would that be? Well, you'd get sine theta cos theta plus cos theta sine theta. Now, let me write that down for you down here. Sine theta cos theta plus cos theta sine theta. Now, we know full well that when we multiply 2 things, it really doesn't matter which order they're in. These could be switched. These could be switched. So obviously this can also be written as sine theta cos theta. And we can see that we're adding something and another lot of it. So we're going to end up with 2 sine theta cos theta. So deriving that formula from this one is dead simple. You just sub theta in anywhere there's an alpha or a beta. And the same for each of these 2. This one's even simpler, I think, if we had the cos of theta plus theta. Obviously, we'd have the cos of 2 theta. And what would we get? Well, we'd get cos theta. That's cos theta all squared. And remember that when we see this, we know that what that really means is cos theta all squared. And you can write it this way if you want, but it's really important to know that when we're writing it this way, that is what we mean. And then we're going to subtract sine theta times sine theta, which obviously is sine squared theta, or sine of theta all squared, however you prefer to write it. And then this one follows on much the same. The tan of theta plus theta would be the tan of 2 theta. And if you had tan theta plus tan theta on the top, you'd get 2 tan thetas. And on the bottom, 1 minus, that's the same. And tan theta, that would just be tan squared theta, or the tan of theta all squared. So these ones here are not on your reference sheet, but these ones are. So I think it's quite straightforward when you need to use these, and if you haven't memorized the formulas, that you can actually use these straight off your reference sheet to generate those. As with anything though, the more you use it, if you can remember them, then it saves you looking them up and having to think it through each time. So lots of practice with these will help you really cement these formulas in your memory. Now, the double angle formula for sine of 2 theta and tan of 2 theta is pretty well always going to look like these. But cos 2 theta can take a couple of different forms. And the reason for that is that it's got cos squared theta and it's got sine squared theta in it. Now, let's just go back a step to our basic Pythagorean identity. We've used this lots of times already. Sine squared theta plus cos squared theta equals 1. This is something that we already know. And if we rearrange this to get the cos squared theta by itself, it's really just a matter of subtracting sine squared theta from both sides, and we get this version of it. And if we want to get the sine squared theta by itself, then we have to just subtract cos squared theta from each side, and we get this version. So these 2 are just alternate versions of this identity that you already should know well. So if we sub either of these in here, we're going to be able to generate 2 more different forms of cos 2 theta. Now, why would we want to do this? Well, this basic formula that we've come up with here, and you can see how we got it, it has cos squared theta and sine squared theta in it. But if we make one of these replacements, we're going to be able to come up with a formula that actually only has sine squared theta or cos squared theta in it. And that can be really handy when you only know one of those or the other, so you can take your pick of which version you want to use. So you don't need to necessarily memorize all 3, although it's really handy if you do know them. but you need to be able to generate them to use them whenever you need them. So let's think, what would happen if we subbed in 1 minus sine squared theta, because that's the same as cos squared theta, if we subbed that in here? Well, we'd get 1 minus sine squared theta minus sine squared theta, wouldn't we? So what we would have is 1 minus 2 sine squared thetas. Okay, does that make sense? Because we've got 1 minus sine squared theta there, minus another sine squared theta, so we're subtracting 2 lots of sine squared theta. All right, what would happen if we subbed in this 1 minus cos squared theta for sine squared theta? Well, we'd still start with the cos squared theta, wouldn't we? And then we'd subtract, let's write this one down to show our working, then we would subtract all of this in brackets, and what we'd get is that. Now, we would have cos squared theta minus 1 plus cos squared theta. So we'd actually end up with 2 cos squared thetas, wouldn't we? Minus 1. So we can write that more simply like this. So you can see my working there of how I got it, and here is the finished product. You can write down the working line and the finished product line if you like, or just write down the finished product and reason that you get them by subbing in these.